In part 2, we're going to solve some triangles. We'll start by using special right triangles. We saw these in geometry last year. First one's the 30, 60, 90 triangle, whose sides are 1, 2, square root of 3. The short leg is 1, hypotenuse is 2. The longer leg is square root of 3. Memorize that triangle. The other is the 45, 45, 90, whose sides are 1, 1, and square root of 2. Memorize that triangle also. And you also need to memorize the formulas for sine, cosine, tangent, cosecant, secant, and cotangent. Lots to memorize in this lesson. All right, we'll use these by then using them to find the exact values of things like sine of 60 or cosine of 45. All right, let's use this diagram to solve the right triangle if measure of angle B is 45 degrees and side C is 5. Notice the capital letters represent the angles and the lowercase letters represent the sides, and the sides are opposite the corresponding angles. So side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. Well, since we know two of the angles, the first thing we can do is find angle A. So we can subtract the two acute angles. Should have to add up to make 90 degrees. So 90 minus 45 is 45. That makes it a 45, 45, 90 triangle. So we can use the special right triangle. All right, if I'm looking for side A, and I use the angle they gave me, so I'm using this angle here that they gave me, this side A would be the adjacent, and I know the hypotenuse. Adjacent and hypotenuse is cosine, so that's why I'm using cosine. It's adjacent over hypotenuse, A over 5. Well, if I look down below, and here's my 45-degree angle, the adjacent is 1, and the hypotenuse is square root of 2. So adjacent over hypotenuse is 1 over square root of 2. So the A over 5 is from the top triangle, the 1 over square root of 2 is from the bottom triangle. So I can take that and cross multiply, or multiply both sides by 5 is what I did. And I got 5 over square root of 2. I can't have a square root in the denominator, so I multiplied the top and bottom by square root 2. All right, to find the opposite, which would be side B, I would use sine, opposite and hypotenuse. Again, trying to use the things they gave us at the very beginning. So that's B over 5, opposite over hypotenuse. From the bottom, the special triangle, that'd be 1 over square root of 2. So take that, multiply both sides by 5, and again, rationalize it, multiply the top and bottom by the square root of 2 to get 5 square root of 2 over 2. All right, let's try this one. This time angle B is 60 degrees and side A is 7. All right, that means that this is our adjacent, is the side that we know. All right, again, we can find our other angle. The two acute angles have to add up to 90 degrees. So that means angle A is 30 degrees. Well, that makes it a 30, 60, 90 triangle. All right, but that picture doesn't line up so well, so I'm going to rotate a little bit so it lines up a little better. All right, so let's start by finding B. B would be the opposite. So opposite and adjacent would be, because I'm using what I have, opposite and adjacent is tangent. So I'm going to go tangent of 60, I'm using the angle that they gave us, is opposite over adjacent, so that's B over 7. On the special triangle, opposite is square root of 3, adjacent is 1. So I have the B over 7, it's the square root of 3 over 1. take that proportion, multiply both sides by 7, and you get b is 7 times the square root of 3. Now to find c, c is the hypotenuse. Going with what I have originally, that's back to a, so that's adjacent and hypotenuse, that would be cosine. Adjacent over hypotenuse. Alright. Adjacent over hypotenuse would be 7 over c. And the special right triangle, adjacent would be 1, hypotenuse is 2, so it's 1 over 2. So 7 over c equals 1 over 2. Take that proportion, cross multiply, because c is on the bottom this time. 1 times c equals 7 times 2, or c is 14. And now we know everything about the triangle. Let's try another one. All right, this time we know angle A, but it's 32 degrees. That's not a special right triangle. So we get to use our calculator, what you've been dying to use. All right, B is adjacent. All right, let's find side A. Side A would be the opposite, because it's the other side of the triangle. Oh, I guess we should start by finding the angle first. The two acute angles add up to make 90. So 90 minus the 32 is 58. I'm going to use the 32 just in case I made a mistake there. So opposite and adjacent is, see, that'd be tangent. So tangent of the angle is the opposite over the adjacent. So it'd be tangent of 32 is A over 10. Now if I multiply both sides by 10, I'll have A by itself. So if I multiply both sides by 10, A is 10 times a tangent of 32 degrees, which is about 6.25. Now, I want these exact if possible. Well, that means if it's 30 degrees, 60 degrees, or 45 degrees, we have exact because we have the special right triangles. If it's not one of those special angles, then we just have to use the calculator. If you are not getting 6.25, hit the mode button on your calculator. Make sure that it is in degree mode. All right, let's jump to the other side. C, the hypotenuse. I'm going to use what they gave us originally. So it's adjacent and hypotenuse. That would be cosine. Cosine's adjacent over hypotenuse. So cosine of 32 would be 10 over c, adjacent over hypotenuse. Multiply both sides by c to get it out of the denominator. And then divide, since it's times there, divide both sides by cosine of 32. 10 divided by cosine of 32 is about 11.79. And now we know all the sides and all the angles of this triangle. All right, our last one. Find the distance between Powell point and Woodforce point. All right, so in other words, we need to find y on our picture. All right, so here's our angle. This 2 miles, that would be the adjacent. And the y looks like the hypotenuse. So adjacent and hypotenuse would be cosine. So I can say cosine of the angle is the adjacent over the hypotenuse, or 2 miles over y. Multiply both sides by y to get it out of the denominator. And then divide both sides by cosine of 76. You get 8.27 miles.